In this session, we'll talk about object orientation programming. We'll talk about definition, fields, constructor, and methods, particularly getters and setters. Finally, we'll talk about how to create an instance of a particular object or a class. Object orientation programming refers to this paradigm of programming that deals with objects. In most of the time, this classes corresponds to a blueprint. A blueprint is a drawing or a structure or a layout, something that gives us instruction characteristics and how to develop something in the future. Sometimes we have seen blueprints when we construct buildings, maybe bridges, or some extension of your house. The whole idea to create these classes or blueprints is to duplicate the access of information so we don't have to repeat in the generation of these objects. These duplications will allow us to generate multiple items of the same type. For example, if you want to create a house, an apartment, or store, you only need one blueprint and then eventually generate thousands of them. Here's an example of a blueprint. Some authors, they call it the cookie cutter because the only thing you need is to have some dough, and with that cookie cutter you can generate a lot of different items. For example, here we have the blueprint of a building. Here we can generate where exactly are the stairs, where are the classrooms, where are the restrooms, and maybe other items. So this is very useful for us or for whoever wants to give a maintenance of the department or the building. They already know where to go and how to access it. One of the most important items is to recognize what is a class and how this notion of a class corresponds to the blueprint in an object. An object, when we develop or we generate, is called an instance. An instance is basically an actual object generated based on the description of a class. But the class are composed by a couple of items. Particularly, we need three of them: the fields, the constructors, and the methods. The fields are the characteristics of the object. This is what makes an object unique. Similar fashion, when you create or you provide the most characteristics, the more accurate that object is. The constructors are in charge of initialize all the fields of the actual class. When I refer to all the fields, is that sometimes we don't have access to these fields, so we need to provide them the default value. We have seen this example. We just create a string, they always give us the value of null. Or when we create an int for representing some value, it gives Java will give the value of a 0 because of the default value. Methods are the functionalities. We have seen a couple of them through this whole course. Next int, next double, next line. Those are methods or functionalities of scanner. To uppercase, to lowercase, char add, dot length. Those are methods or functionalities of a string. In similar fashion, we have seen many of them through this whole process of that we've been programming. We didn't know there was objects, but this is what encapsulates an object itself, containing those three items: the fields, the constructors, and the method. Now it's time to create our own classes based on their needs or the descriptions that some authors, clients, or maybe some needs that we have to generate an object. In this session, we'll talk about a case study for robot. Particularly this type of robot. You might or might have not seen this particular robot, but those are vacuum robots. Some of them, they have fancy names. Some of them, probably the most famous ones, are called Roombas. But in reality, you can generate or create some kind of robots on your own. As you can see in this particular example, you just need a Raspberry Pi, a microcontroller, and that chassis that you can actually have some wheels to move north, south, east, or west. We will create the interface that generates this robot. The first thing we have to do is to generate the fields. The fields are the characteristics, what makes this object unique. And there are several fields in this particular item called robot. A robot has wheels, sensors, in order to make sure if you don't have something in front of you, they recognize that. A direction, some have the compass to see where is north or south. Some fancy ones, they have cameras where they can actually recognize object and make a decision based on that. GPS gives you the global position system, which help us to find a location where you're located in terms of X, Y, or Z. A distance to keep track of how much distance in meters or feet that you have traveled. Some of them they have some LEDs that they give you some kind of feedback when you're actually reading or navigating or when you have to go back to the charging deck. For simplicity purposes, we're going to focus on the GPS and the distance when we generate this object called robot. The question is how we represent this robot in Java. So notice that location, we have to break it in two types of coordinates, the X and the Y coordinate. X will be an integer representing the longitude. Y, another integer representing the latitude. This can be even more complex if you want to have a double to have more precision. Only for demonstration purposes, let's keep it simple with an int. We also will have distance. Distance will represent a whole number in order to represent the longitude and latitude navigated through this robot. This is very important, especially because if you are on a remote control from the robot, you need to know how much gas you need to put or what kind of energy you should put based on the distance that you travel. Before we jump into the code, let's introduce this notion of UML, also known as Unified Modeling Language. A UML is a diagram and is very important for software engineers and programmers because that will demonstrate a contract of what exactly this software will develop. It's a description of all the objects that you're going to create in the future in any programming languages. Yes, we're using Java, but Java maybe will not be the only programming language that you will use in the workforce. Sometimes even programming languages expire, and we might need to adopt it to a new programming languages. But don't worry, the UML never expired. It also provides the flexibility to write that program in any language. This diagram will describe the fields, constructors, and the methods corresponding to the encapsulation and modifiers. This also includes the data types, the return types of certain methods, and of course the parameters that you need in order to execute in the program. This is the UML for the robot. Let's inspect what each component takes place. The very first thing is the name of the class. This is robot. And they usually put at the very, very top of that box that you see there. This smaller box represents the fields. These are the characteristics and what makes an object unique. Let's inspect what is inside of there. These are the constructors and methods. These are the functionalities of this object called robot. Let's inspect what is inside of the fields. The very first thing you see there is called the encapsulation modifiers. Java supports a couple of those modifiers in terms of visibility. Public is denoted with the plus sign, private with the minus sign. The difference between public and private is that public methods, everyone can see it once you create a new instance of the object. Where private, they're only accessible by this class, in this case, robot. There's other additional encapsulation modifiers, for example, protected, very widely used when you inherit objects from a different class. Protected allows us to do this separation of duties to see only certain elements can have access of these fields, whereas the rest can be private or public. There's an additional one called package, and package only belongs when you create large programs and then only communicate along those packages or subfolders. This is an example how we retrieve this information in code. The fields are composed by the encapsulation purposes. This is private, followed by the data type. We all have integers, so therefore the data type that should be defined just after the encapsulation type before the name of the variable, followed by the ID. Make sure you don't include any initial value at this point. We're only declaring the fields or the characteristics of the object. The next item are the constructors. Remember that the constructors are responsible to initialize all the fields. Now notice that we have three types of constructors. We have robot, open close parentheses, robot with 2 integers, and robot with 3 integers. Also notice that there's a keyword there called this. This is used to refer that any element defined or used in this particular class called robot. This is very important because it refers only to the items in this particular class. Very useful when you develop mobile apps. Notice that every time we're referring to the fields, we use this.x, this.y, and this.distance. Also notice that every time we're referring to this, it helps us to distinguish between the fields that we provide in this class versus the parameters. This is called shadowing. For example, in customized constructor number 1, we provide 2 parameters, int x and int y. But notice that we also have the fields x and y. In order to distinguish which one you are referring to, this.x is a field, whereas x is a parameter. This.y is a field, where y is a parameter. Notice that we provide a default value for this.distance for 0 because distance is an int. We can also have another customized constructor when we provide all the fields. Notice that here we have x, y, and distance as a parameter. But also we have a constructor that initializes x and y in this class. Is the customized constructor number 1. That's why in this line, we use this, comma, this, open parenthesis, x and y. That invokes that particular customized constructor number 1. When you have multiple methods or constructors with the same name, this process is called method overloading. Method overloading allows us to be flexible with the computer user when we invoke a particular method. Method overloading is one of the features of object orientation programming and is widely used in programming. This particular item is invoking the second constructor, constructor number 1. Java is smart enough to recognize where is this located. The next item is called getters, also known as accessors. Getters and accessors permit to retrieve data from the private fields. Very useful. Whenever you are outside of the class robot and you want to extract information, for example, x, y, or distance, let's pay attention how these are defined. The plus sign represents the encapsulation type. All getters usually are public because we want to provide this flexibility to everyone who is outside of this class to access x, y, and distance without any problem. That's why we provide the plus sign. The next things are the return type. Getters have return type. In other words, they're a return-based method that will allow us to retrieve the field data type that we're going to report back whoever is accessing it. Getters starts with the word get. By convention, we use camel case style in order to basically have get and then the name of the field. You can see here get x, get y, get distance that will permit the computer user to access them without any problem. The next items are the setters, also known as mutators. The setters will permit to change the state of the object by updating specific field. This one, in contrast from getters, they do have parameters. Let's inspect what happened. Some setters are often public methods. I know it's a little bit weird to say why you will permit such an action so everybody can access it, but only for demonstration purposes, we're creating public. But we don't want anyone to touch our fields. But in this time, we're going to make an exception to providing a public method as a setter. They usually are void method. We don't want to retrieve any information after the change of the state of the variable. Setters usually start with the word set, followed by the field that you want to modify. In this case, we use camel case style as well to set x, set y, and set the distance. And finally, setters, they do have arguments. These parameters allows us to change the state of the object by providing that parameter and modifying the current field. You can see here we're modifying this.x by providing the parameter provided there as x. This does y gets y, and this.distance gets the distance. Finally, we have more methods that will allow us to perform some functionalities. We're using the robot, and the robot has x and y in distance, so might as well have some mechanisms, some functionalities that allows us to manipulate those values of x, y, and distance. You can see right now that we have a couple of them. For example, we have move north that will allow us to move the y coordinate by 1. Notice that the distance is also being increased because every step we move to the north, it will increase distance. As a matter of fact, distance changes in all of them. As you can see, move south, move east, and move west, they all manipulate the distance. The only difference is between north and south is that one goes to the north, one goes to the south, and one increases and decreases. Where move east and move west, you manipulate the x coordinate. The last element that you can see here is the TwoString. The TwoString is a special method that we inherit from our super ancestor called object. The TwoString will provide us this textual representation of the object. We usually manipulate different fields. In this case, for example, x and y. You can see here how we use the power of concatenation in order to provide that good output. The distance is also provided, so it can give us a very nice description of how much this robot has trouble. What we can see here is the class object. Object is the superclass of all objects in Java. Object is the parent of any object you can believe it. JOption pane, scanner, string, those helpers like integer and double, print writer, file writer, math, you call it. So here what we can see, one method in particular, equals. We have used equals on string, but interestingly, we can see here TwoString. The TwoString is one of those 11 methods that we inherit from the class object. And notice that the return type to the left-hand side is a string. Again, it gives us a small description saying that this returns a string representation of the object. And we have seen this in the past. Let's recall. This is the main. When we create an instance, as you can see on line 3 of robot, we create this by using the default constructor or the non-argument constructor. The only thing we're trying to do, or we attempt to do on line 4, is to print raw, which is the instance name of robot. Notice that we haven't declared any TwoString in the class robot. Let's see what happened. If I save, compile, and run this program, we're gonna get the following output. This looks familiar. The first part is the name of the class, followed by this @ sign that is basically mentioned that is located at, and then this funky address. This is the hexadecimal address location where the object is located. We have seen this in the past with arrays. But what happened if we define a TwoString in the class robot, similar to the one that we show in the past? Well, if we save, compile, and run this program, we got a very different output. Now we have the distance, the value of x, and the value of y. Notice that we didn't do anything different from robot demo. This is more informative versus the other one. Which one you prefer? The one without TwoString or the one with TwoString? Well, if you reality just don't care about the information of our robot, maybe you don't want to overwrite a TwoString method. But if Granny is using your robot that you create, maybe you want to give a very meaningful representation of this object. which is the lowest part that you can see here. Inheritance is another feature of object orientation programming. One of the characteristics of object orientation programming is inheritance, and it supports the ability to extend certain attributes from a superclass to a lower class. Java supports single inheritance as a mechanism to address this feature. The idea here is to provide a feature in one superclass and then override that is in the subclass that can allow us to reuse code from a superclass. Inheritance is probably one of the main features used in industry nowadays because you don't want to start anything from scratch. You want to reuse code and not only that, adopt it in a consistent and coherent way. We're going to introduce two keywords, extends and super, that they only takes place in the inheritance stage in object oriented. The keyword extends permits to link the class to a superclass, whereas the keyword super invokes superclass fields or methods or other attributes as long as they're not private. As you probably remember, the relationship that we have in inheritance, we must have a superclass and a subclass. The feature here is that the subclass inherits attributes from the superclass, and we denote it in a UML diagram by using this arrow. Remember that inheritance is considered to be a relationship. What does that mean? For example, when you have a superclass course, we might have two types of courses, a face-to-face or an online class. This extension will say a face-to-face course is a course. But we can also have this hierarchy when we can have an online course that is also a course. So now you have this family, face-to-face course and online course, that they both extend the attributes of a course. This is called is a relationship. In our example, we're going to have our superclass robot, but we're going to extend it to a different feature. We're going to create a more sophisticated robot called a drone. A drone is a robot, but also has more features. But how can we know it's a robot? Because a drone moves to the left, to the right, to the north, to the south. Those are attributes that we have from the robot. But not only that, a drone has this ability to fly. So we can extend our notion of robot through a drone by using inheritance. It means that drone will now take place in this hierarchy in Java that we already know. In other words, drone will inherit all the attributes from robot, but robot will inherit all the attributes from our class object. Now we have this hierarchy that we have established by using extends. How does this look in the implementation? When you define a class drone, the word extends must be right before the superclass that we're going to inherit. In this case, will be robot. Extends will permit this contract that will allows us to basically say, hey, I will inherit everything comes from robot. I am drone. Notice that we have a field on line 2 called Z, which will represent the actual attribute that makes this class drone unique. But what happened to X and Y? Those are attributes that comes from robot and we will inherit thanks for the word extends. Z in this case will represent the altitude and is what's going to make the drone unique. Notice that we have also constructors. Friendly reminder, our constructors are responsible to initialize all the fields. The constructor that we have in line 4 corresponds to the non-argument constructor. The one on line 8 is a customized constructor. The one on line 4 doesn't take any parameters, so it will create just a very basic default drone. Whereas the one on line 8, it will contain X, Y, the distance, but also the altitude. Notice that we have the keyword super. The keyword super must be the very first line after we define the constructor. Super invokes the superclass methods or constructors. And it basically tells the superclass that we're going to use those constructors in this class. Notice that on line 5, we're using the super constructor for the default constructor on robot. And on line 9, we're using the super constructor for the customized constructor, the one that takes 3 parameters. After you execute that, you must initialize the remaining fields. In this case, we'll initialize z to 0 because it's an int, as you can see on line 2. But also we're going to initialize 10 with the parameter value by using the proper this.z gets the parameter z. How about getters and setters? Every good practice must include them as well. We're going to include getZ, which will give us the altitude in this class, whereas setZ will give us a parameter and you initialize it with the this.z accordingly. We probably need more methods or functionalities. We're going to have move up and move down, which means that we need to navigate through the z coordinate, the altitude. So move up basically increase the coordinate z, where move down will decrease it, as it shows in line 19 and line 25. We also need to update our distance. We will use a temporary variable called d. In order to set the distance, once we obtain it, we can increase it in both methods and then set it by using the setter setDistance. This implementation of drone basically inherits all the attributes from robot, and most of these methods must have a different type of encapsulation. That is why, for example, setZ, move up, move down, they're all protected. And the reason why is because we're going to have a collaboration or a consultation between robot and drone. This will allow us to keep the integrity of our fields consistent with the contract that we want to implement. And not only that, it will allow us to extend to a drone and use them in this class. And nobody should be able to touch the fields, for example, X, Y, and distance. If we go back to the TwoString, we will allow us to overwrite the TwoString that we inherit from an ancestor. Notice here that on line 30, we still have the same name of the header, public string TwoString. That doesn't have to change. This is for the reason we overwrite our inherited attributes, in this case TwoString. Remember that we inherit TwoString not only from our parent, robot, but also from an ancestor or grandma or grandpa called object. Once you declare public string TwoString, you overwrite whatever you inherit from your ancestors. Notice that you can still use the one from the superclass as is described here. Super.TwoString will invoke the superclass TwoString. Let's see how this takes place in the inheritance hierarchy. Drone inherits the TwoString from the robot, but also once we inherit, we can override it by creating the TwoString. In similar fashion, robot inherited the TwoString from an object, but that TwoString was not very helpful because it contains the hexadecimal address location where the robot was going to be located. So that's why robot decided to overwrite it. Here we're invoking our ancestor, in this case, our parent's robot. Super TwoString will call the superclass from robot and will give us the output that we expect. We use the power of concatenation to make this TwoString unique. That's why we provide aerial to provide a feedback that we're dealing with the drone. Finally, we concatenate also the z coordinate to whatever the TwoString from our ancestor will be. And makes a lot of sense because it will report X, Y, and now the Z. As you probably remember, this will take place first by robot inherit the TwoString from object and overwrite the TwoString. Finally, the drone will overwrite the TwoString coming from the robot. So when we run it, when we create the robot, this is what we got from the object TwoString. When we overwrite it, we got something more fancier when we got the distance, the X, and the Y. But when we overwrite the TwoString from drone, the same image that you're seeing right now from line 30 to 32, now that will also not only overwrite the TwoString from our ancestor robot, but also will concatenate aerial distance. We inherit the TwoString, which is distance x, y, and at the end we concatenate the z. This is very powerful. As a matter of fact, if you create your Javadoc, it will generate the following thing. You can see here in the square that will demonstrate that we have a hierarchy already. Notice that object has a child, robot, and robot has a child, drone. So now you can see how Javadoc, when you create the Java documentation, it will recognize this hierarchy automatically. When we see the methods, it will not only generate the getZ and setZ, but notice how we inherit also some attributes from robot. Notice that here we describe that there is a couple of items here that we inherit from the class robot. This includes get distance, get x, get y, move the east, move north, south, west, print info, set distance, set x, and set y. These are inherited from the class robot. And not only that, it will provide us also a description which one we inherit from the class object. You can tell right away that we don't have anymore the TwoString because we override it. As a matter of fact, robot doesn't have the TwoString. It got overrode in the class drone. How about we want to prevent this process? There's a process to inherit this flow of inheritance, and this is by using the keyword final. The keyword final will prevent that future extensions of this instance will take advantage of overriding. And it's simple. In the class robot, we need to include the keyword final just after the encapsulation public and just before the string, in this case, and just before the return type, in this case, string. This will prevent that elements like, for example, drone will extend the inheritance. When we create our instance in our main, we will create a drone and then we'll interact with the computer user as the simulated version of how many distance you would like to run it. Suppose that you reach 20, you can move north, south, east, west, up, or down based on the description. This line 6 will basically create the interaction with the computer user and extract the command. Or in line 7, we'll extract the command from the computer user and store it in a string. The rest is just a multiple option, how we want to move through those directions. It's a decision maker based on the computer user's input. On line 29, it will print the current state of the drone. Notice that the TwoString is not included, but that will include the entire description. And this is one of the perks that we got once we inherit the TwoString.